Today we are going to look at how to verify basic trigonometric identities, and this is the part 1 of this video. Now, whenever you are being given trigonometric identities to verify, what you need to do is that you take the side of the identity, either left side or the right side of the identity given to you, the side that gives you in a complex form for you to work with to get the answer that corresponds to the other side. Let's look at these various examples on the screen. The first one says the identity should be equal to cos square theta. So you can see the left hand side is more complex to the right hand side. So you are going to verify the left hand side to be in the same form of the right hand side. So we are going to take left hand side and work with. So we have cosec square theta minus 1 over cosec square theta. This is what we are using and going to work on this to get the result at the right hand side. So in this case, we need to remember some of our basic trig identities that we have talked about in the previous video. So cosec square theta minus 1 is also an identity which can be derived from 1 plus cot square theta equal to cosec square theta. So in this case, we make cot square theta the subject and send this 1 to the side of the cosec square theta, and that will give you cosec square theta minus 1 to be cot square theta. So you're going to replace the numerator by cot square theta. Then we repeat the cosec square theta over here. Now we need to also change cot square theta, and that is in the form of cos square theta over sine square theta. So we have this to be cos square theta over sine square theta, and being divided by cosec square theta is giving us 1 over sine square theta. So we're going to reciprocate the second fraction. So we have cos square theta over sine square theta times sine square theta over 1. So over here we'll have sine square theta here and sine square theta here. So I'm going to cancel out the common identity. Then you are going to be left with cos square theta, then over 1 times 1 over 1, and that gives you cos square theta. So the left hand side has been proven to be equal to what we have at the right hand side. So this is how we can prove basic trigonometric identities. Let's have a look at more examples. So we have example number 2. So you can see the right hand side is more complex than the left hand side. So you're going to work with the right hand side. So taking its identity, we have 1 over 1 minus cos theta, then plus 1 over 1 plus cos theta. We find this LCM, and the LCM is going to be 1 minus cos square theta, because it is in the form of difference of two squares. Then the numerators, we are going to get 1 plus cos theta, then we are going to get 1 minus cos theta at the side. Now we have 1 plus 1, that will give you 2. Cos theta minus cos theta, that will cancel out. So we have 2 remaining at the numerator. Then we have the denominator to be 1 minus cos square theta. Now we have the identity called sine square theta plus cos square theta equal to 1. So we can deduce this identity from our basic identity over here, we need 1 minus cos square theta, and that will give you sine square theta will be equal to 1 minus cos square theta. So which means the denominator is equal to sine square theta. So you have 2 over sine square theta. And this will give you 2 times 1 over sine square theta. And we have 1 over sine square theta is giving us cosec square theta. So we're going to have 2 cosec square theta. And this is verified according to what we have at the left hand side. So after going through steps like this, our identity will be verified. So whatever identity given at the left hand side and the right hand side should be in the same form. Despite that, one of the side is complex for us to deal with to get the same result at the other side. Let's have a look at another example. So we have this identity to prove whether they are equal. So the left hand side is more complex than the right hand side. So we are going to work out from the left hand side. So taking the identity from the left hand side, we have cos square theta plus 1 multiplied by sine square theta minus 1. Then in this form, we are going to use the identities to replace what we have in the bracket. So cos square theta plus 1 will give you, so let's come to this side. We have 1 plus cos square theta equal to sine square theta. So cos square theta plus 1 is the same as 1 plus cos square theta, and that will give you cosec square theta multiplied by sine square theta minus 1, and that will give you, to make, so sine square theta minus 1 will give you negative cos square theta. So here you are going to get negative cos square theta. So we multiply, you're going to get, so you're supposed to change the cosec square theta, that will give you 1 over sine square theta multiplied by negative cos square theta. So this is over 1. And our result here is going to be negative cos square theta over sine square theta. And we know cos square theta over sine square theta is going to be cot square theta. So that is going to be negative cot square theta. So this has been proven to be equal to the identity at the right hand side. Let's have a look at the last identity. Over here we have the left hand side to be complex, the right hand side also to be complex, but we need to take it from the right hand side because it has a fraction, and we need to deal with a fraction from the identity. So we're keeping the left hand side and work out with the right hand side. So at this point I'm going to use the right hand side. So taking the identity at the right hand side, we have sine theta over 1 minus cos theta. So you need to introduce conjugates to this fraction. So we're going to multiply the fraction by its conjugate. That means changing the minus at the denominator to plus. So we have 1 plus cos theta over 1 plus cos theta. You know, when you cancel out this, you still get the same question. So it has not changed anything. Now we need to multiply the numerators and the denominators. So we have sine theta will multiply 1 plus cos theta all over. Then this is the multiplication. So difference of 2 squares. So we have 1 minus cos square theta. Now over here, we are going to use the sine theta to work at 1 plus cos cos theta. all over. Now let's look at this one. 1 minus cos square theta will give you, so that is 1 minus cos square theta is going to be sine square theta. So I'm going to replace this by sine square theta. So sine theta and sine square theta is going to cancel out the power. So we have sine theta will cancel out the power of sine square theta. So you are going to get 1 plus cos theta over sine theta. So we are going to split the denominators to the numerators. So over you are going to have 1 over sine theta plus cos theta over sine theta, because that's a common denominator. So when you give it out to the numerator, so you're going to get something like this. Now, according to trig identities, we know that 1 over sine theta will give you cosec theta. Then cos theta over sine theta will give you cot theta. So we have gotten the identity at the left hand side, which is they are equal. So these are many more trig identities that we are going to prove in the near future. So this is part 1 of this video. The part 2 will soon come, and it will also answer some of the basic trig identities and how to verify them. Thank you very much for watching. Don't forget to like and subscribe to my channel.